All right, we are almost done with Algebra 2. This section is going to be on geometric sequences. We know a sequence is a list of things, right? If I asked you to repeat back the sequence, I'm going to list a bunch of different things like hammer, nail, saw, hammer, something ridiculous. Well, a geometric sequence is a sequence where each term is the product of the term before it. So, in other words, and a constant ratio. A constant ratio, or a common ratio. Lots of big words used there. What it really means is that you're taking a number and multiplying to get to the next number. And then you take that number and multiply to get to the next number. The formula looks like this. To find any random term, take your first term, multiply it by r raised to 1 less than what term you're trying to get to. A1 is the first term, or in other words, your starting point. R is your common ratio. What you multiply by to get to the next one. And n is any positive integer. What it really stands for is the numbered term. So take your starting point, multiply it by your common factor to whatever power you need to get to. So if I told you we were going to start at -10, we're always going to multiply that term by 4, and I want to get to the second term. You're going to take -10, because that's what I started with. You're going to multiply that by 4 to 2, which was my n, the term I was trying to get to, minus 1, because I already have the first term. So -10 times 4 to the power of 1, well, that's -40. Let's jump over to number 3, because apparently I forgot to change the numbers. Now, normally I subtract 1, because that's where I started, but I'm going to start at term 3 this time. And I'm going to say I started at 9. I'm going to multiply it by 3, and I want to get to the 7th term. But I already started at the third term, so I'm going to subtract 3. So I have 9 times -3 to the 4th power. So what is -3 to the 4th power? 27 times 3? 81. So I have 9 times 81. Which is 729. The 7th term of that sequence would be 729. If I did number 4, no, let's do a different one. No, let's do number 4. I like number 4. If you're starting at the 4th term, I know that because I have a little 4 here, I'm multiplying by 2 to get to the next term, and I want to get to term number 10. So I'm going to start at the 4th term, which was 16. I need to multiply it by my 2. And I'm trying to get to the 10th term, but I started at the 4th term. So I have 16 times 2 to the 6th. 2 to the 6th. Well, what is 2 to the 6th? Pull up a calculator if you need to. 2 times 2 times 2 times 2. 64? So 16 times 64. $1,024. Now 6, 7, and 9 all start at term 1, so you're going to subtract 1 like we did for example number 1. And if you want, I will post those notes available to you as well. But let's go to the next section. All right. I want to write the equation. I'm given a sequence, but now I have to find A1, R, and well, that's kind of it to write my equation, right? So I need to figure out where I'm starting at. Well, I started at 500. And I need to figure out how did I get to the next term? Well, I know I had to multiply by something, right? So what if I take term 2 and divide it by term 1? What is 350 divided by 500? So 350 divided by 500. So I've got a 7 over 10. So A to the n is equal to my starting point, 500, my r, 7 over 10, raised to the n minus 1. Let's do that again for number 11. A1 and r. A1, I started at 8. How do I go from 8 to 32 though? 8 times what gets me to 32? 8 times 4? Or in other words, 32 divided by 8, which is the same thing as 128 divided by 32. So I know my common ratio is 4. If I take 8, multiply it by 4, I'm going to get 32. 32 times 4 is 128. So a to the n is equal to 8 times 4 to the n minus 1. Let's do number 12. I know my A1 I started at 11, and R is term 2 divided by term 1, so negative 24.2 divided by 11. We have 24.2 divided by 11. So on the calculator, you'd get a negative 2.2. And you can leave it as negative 2.2 because it ends. But I like fractions. So I have negative 5/2. Not 5/2. Let's see if Ms. Markle can convert a fraction. 1/5, so 11/5. There we go. How about negative 11/5? So my formula, an, is my first term, 11, negative 11/5 to n minus 1. A1 and R. The only two things I need to find. A1, well, I started at 9. R, 9 times what gets me to 54? 9 times 6. And then double check, is 54 times 6 324? Is 324 times 6 1,944? I think so. So an is equal to 9, 6 to the n minus 1. That's it. Those are our answers when we're asked for the equation. Sometimes we might need to do both steps. Sometimes it might be something like this, and then it says find n equals 6. Well, then you would have to find the equation and plug in 6 for your n and calculate for your answer. I will finish off the last couple of examples for the notes key if you wanted to see those. Otherwise, have a great day, and don't forget to do your homework.